Hello and welcome to the Nova Show. I'm your host, Chris Nova. Welcome to the show. Welcome in, everyone. How's it going? Welcome to the show. Here at the Nova Show, we do what I want when I want because it's my fucking show. Happy Sunday. Yo, let's go, says Mally Wolf. Yo, let's go. How's everyone doing? I hope you all missed me. I missed you. I love being able to come to these Twitch shows, these Twitch streams. And I don't know. I feel like Twitch is like the local bar. It's like it just feels good to be able to know that you can just like stumble in here and everything's gonna be okay. There we go. That's a good color for today. Doing good, moving into a new place in 2 weeks, and I'm so excited. That's awesome. Looks like we have a lot of people here. Let's say hello to everyone. Let me adjust my microphone and then we'll say hello to everyone. Cool, so let's see who we have here. We have Show Kernel, we have Mouseme, Beholder, Holly Computer, Owen Codes, Majestic Mac, Mallywolf, Adius is here. I think it's everybody. It's a chill morning this morning. I bet more people are gonna trickle in as they start to wake up. It's 8:30 on Sunday morning here on the West Coast. So how's everybody doing? Yeah, and depending on what corner of the bar you're in, there's some good shit. New Step says, "Hey, Chris," with 1,000,000 exclamation points in all caps. What up, New Step? 4 p.m. for Owen Codes. Oh. So one of the things I've been doing this year, so I've started to get a bunch of gray hair. I'm getting really old. I'm just fuck it. I'm just going all in. I'm just letting it ride. New Step says, "I was worried about you. I hadn't seen you in a long time." Thank you. So it's been a rough couple months. Well, it's been rough in some ways, but really good in other ways. And I think my long-term goal was to get back to Twitch without any of the other bells and whistles. And so here we are. We're back to Twitch. I'm working on a Rubik Cube. Awesome. Awesome, awesome. Look, I think I can turn my little on the air sign on. Let's see. Can you see it? No, you can't really see it. Let's see. There we go. So yeah, so it's been an interesting few months. One of my goals now that things are more settled at work and that I am coming back here from my vacation is that I want to start streaming more. So I don't know how it's gonna go during the week. This is the big unknown. Now that I'm back on the West Coast, you know, I work with folks on the East Coast and folks in Europe, and so 7 a.m. for me. So roughly an hour and a half ago, whatever an hour and a half ago would have been in your local country, that's usually when my workday starts. And I think people in other parts of the world are usually ready to like unload for the day. Like they're done, they're checking out, they're ready to go. And they're like, "Here's what I did, here's your problem now, peace out, sayonara." And so anyway, I'm I used to stream in the mornings. I don't think I will be able to do that anymore for that reason. How is vacation? Are you full of energy and rest? I'm not full of very much. I would say have I rested? Yes. Am I full of energy? Yes. But I would say that my mind is relatively empty, which is good. Internet needs its own time zone. The internet does need its own time zone. That's a good call out. So yeah, so I actually haven't had any coffee yet this morning. So usually what I'll do is I'll start the countdown timer on my show, and I'll sit here and I'll kind of like think about what I'm going to do throughout the show and drink a little bit of coffee before the show starts. But today, cheers. Today y'all get to drink coffee with me and we can talk through what we're going to stream about today on the show. Belly Jean says, hello, Chris. Please don't hijack my TCP, please. Thanks. Don't worry. I don't plan on hijacking anybody else's TCP. I think it's a good tabula rasa fresh start. Nice. Yeah, it is a good fresh start. Yo Nova Wave. Oh, it's from Prexton. Hey, Prexton. Or Preston. I always just call you the wrong thing. I feel like you're like one of my family members now, because I love you because I deliberately mess up your name all the time. It's all good. How's life? How's life, Ask? How you doing? Thank you for the follow, everyone. We've got a lot of followers today. This is one of the things that, when I was last streaming a couple months ago, I think I kind of had plateaued, so it feels good to be like back with like new, fresh energy. We have a few problems we're gonna have to solve as a community at some point. I'm still not convinced on what the right thing to do with the Discord, and I suspect people want other alerts, and I suspect there's like some opportunity to like expand into YouTube and maybe even set up my own streaming server or something at some point. I don't know. We gotta figure all this shit out. We gotta, like, do we want me to continue to stream on Twitch? I think so. I think Twitch is definitely where it's at. Do we want me to stream on YouTube? I think there are people who like YouTube, and we can do the recordings there. And then I think there's also like some exciting prospects of like just going full renegade pirate streamer, and then like we can just listen to whatever music we want, and then we can just listen to music together, which like that's a pretty big win. YouTube is free ads for the Twitch stream and vice versa. Nice. How did you get into cyber? I didn't get into cyber. Cyber got into me, kid. Right, I don't know. I just like computers, I guess. Follow the dopamine. I don't know, like, if you really want to know the high level story, so there's this very common, like, phenomenon, like, we can call it the Nova phenomenon for now, but basically, there's this moment in most, I wouldn't say most marginalized people, but, like, also, I'll go ahead and make the assumption and say most marginalized people in this case. There's this phenomenon that happens when you're a marginalized person and you get into tech. So you join tech because it's full of hopes and dreams. So we're all getting into tech for the same reason. It's got money. It's got hope. It is fun. It's exciting. It'll better me. It'll unlock opportunities. Maybe I can travel. Maybe I can see the world. Maybe I'll learn to do something cool. I'll get like my open source project will get big, and I'll get some credibility and some recognition on the internet, and that will like help me feel proud of myself and feel like I've accomplished something in my life. Like we all kind of get into tech for like the same handful of reasons, I feel like. You know, one of the big reasons for me and for many transgender people is for healthcare, especially if you live in the United States. So here we have this pool of people, most of which are marginalized because, you know, the fact that tech is more open to different styles of life and different cultural backgrounds and religious backgrounds and even like sexual orientation, identity, and skin color, and even just what country and language you speak. Tech is more open to that. And so we get into it because we try to elevate ourselves out of the position we're in now. Or at least we try to address some glaring flaw in, something that's wrong. For me, it was healthcare. Right. I know for other folks, it's quality of life, or it's children. That's a big one for people who have kiddos. And so we get into tech, and we quickly realize that it may or may not be possible, but it's going to come with a lot of bullshit. And some people are here for the bullshit and want to go pursue it, and some people don't. So for me, I got into tech, and I wasn't into cybersecurity. I was just into just tech. I just wanted to build cool systems, right? And so as that continued, I eventually got good at it, and I got better at it, and I became like exceptional at it. And there was this moment, and this is the phenomenon I talked about earlier, where I looked around me and I realized there's two types of people. There were people who were in tech because they needed to be in tech, like me. People who needed healthcare, people who needed who needed something they wouldn't have without tech. And then there were people who wanted to be in tech. There's a huge distinction between these two things. So I looked around and there was these people who had perfectly good childhoods, who went to great colleges, who grew up as a normal American and had money and got married and had kids, and their partner worked and they had money, and they were kind of just like thought tech was fun and was like, sure, another sailboat sounds nice, I'll just work for a few more years and get another sailboat, or whatever, right? And that made me exceptionally angry. And when I think of the word anger, I think of this concept of like, you feel this feeling of this great injustice has been done to you. People get angry when they feel like there's this something's not fair, when justice hasn't been carried out. People get very angry. I was very angry, and when I had this happen, and then I became resentful. I wanted to get even. It wasn't fucking fair. And that's what led me into cybersecurity. And I think cybersecurity is just the word that we use when we say we want to be hackers and talk about it. And I had very much gotten good at computers, like to the point where I was typically the most like useful person in a room. I don't want to say I'm the smartest person in a room, because I hate that mentality. I hate that, like, oh, I'm better than you, elitist. Fuck that. You should kill your ego. Fuck all that. I will say, though, that, like, it's rare for me to sit down in front of a terminal and roll up my sleeves and say, hey, we're going to go do some good old-fashioned computer work, and have somebody who can actually outperform me. And when it happens, I get fucking stoked. I want to be their friend. I want to hang out with them. I want to work more with them. Because I hopefully just found a new buddy. And so anyway, I would say that that's what led me to cybersecurity, was the fact that I could do more with computer systems than most people quickly. And I was very resentful. So anyway, like, I think that is the long story of how I got into cybersecurity. And you can see, actually, this is a great segue. Watch this segue. Watch this shit, you guys. You don't even know how cool this is gonna be. It's gonna be like you're listening to a podcast. Okay, so look here on your screen. I have this project called BoopKit. I wrote this last year, last year. I wrote this last year. I had written, this is a cybersecurity tool I'd written. It's written in C. We're going to be doing another one today called TCP Jack. This one uses eBPF and opens up a backdoor over raw TCP. You can use this to spawn reverse shells, and you can do basically like root access if you already have access to a computer. So this is a backdoor using eBPF, and I had written this specifically for some friends in Ukraine after another fascist country had decided to illegally position some of their armed forces inside the borders of a sovereign country. And they were going through some issues that I can't talk about. And I said, here you go. This should help you accomplish exactly what you're trying to accomplish. And gave them some examples. And they used some of the code in here. And so anyway, this was one of my ways of trying to feel like I did something to help combat the evils of the world. And this is an example of me getting into cybersecurity. I'll be candid, I don't do cybersecurity every day. I mean, I do, because like I'm like an engineer who works on like a public facing service, but like that's not my full-time job. My full-time job is Zoom calls and Google Docs and talking to people. And I just happen to talk about the same type of stuff we talk about here on my stream. You know, we're talking about production systems and network traffic and, you know, all kinds of fun stuff. Anyway, I hope that explains how I got into cybersecurity, and this is a great segue into the work we're doing today because BoopKit is written in C. Today we're going to be writing some more C. We made this decision the other day on my first stream back, and we're working on this new tool called TCP Jack. So I'm not totally sure exactly what this is going to do yet, and that's okay. You're going to watch some of the magic here. We're going to do this a little Bob Ross style. We're not really sure how this project's going to end up, and that's okay. We're just going to kind of follow the dopamine here. I think there's something we can go and explore with active TCP connections, and I think we can do some performance instrumentation in an active TCP connection. If we can, we're certainly going to find out. And so we started to go down this rabbit hole a couple of days ago, and we found what is now my new favorite C library. I had no idea this thing existed. And it's probably already on your computer. I didn't realize it, but it was already on my computer here, on my Arch Linux computer. It's called libnet. Who's heard of libnet before? I'm sure we've all heard of like libssh. And my old favorite one, who knows my old favorite C library that I used to absolutely love to play with? It was one of my favorite ones. It's in BoopKit for what it's worth. I used it in BoopKit. I use it in all kinds of stuff. Who can remember what it is? It's lib something. Who knows what it is? Lib. Lib p. Who knows the rest? It's there. It's in there somewhere. Which one is it? Which one is it? It may not even be installed on this computer. libpcap. That's right, it's libpcap. Let's get it on here because we're going to use it today. There it goes, and we'll install it now. So now let's go into libpcap. Oh, user lib. There we go. So there's the shared object for it. So I guess we didn't get the sources, and that's okay. Or it might even just be pcap and user include. There it is. Here's the header files for it. This is what we want to see. So this is my favorite library here. So particularly this file. And there's a few others in here I like to use. This one is pretty good too. But this one is the exciting one. So this is pcap.h. And we'll talk more about these as we get into them today. And so anyway, there's this library called libnet and user include libnet, I believe. Here you go. So libnet is this exciting new library it's old as dirt, but it's updated recently, which is cool as fuck. Network packet construction. So when I had written BoopKit, I had written this little command line tool here called boop. And this is where, somewhere in here, packets.c. So here, see this create send packet? This is my concrete implementation. We might use this again. But this is my concrete implementation of how to create a send packet using C natively. Libnet does this and more, and a lot more, and a whole heck of a lot more. And if you look, it's used in all of these really fucking cool, obscure network tools that everybody forgets you can do with a network. And so anyway, we're going to be doing this thing called TCP Jack today. And my goal for today is I want to be able to hijack a TCP stream. Hopefully even an MTLS encrypted one at some point, but that'll be out of scope for today. But we're going to try to hijack an existing TCP connection. So I was working on this last night in bed using TCP Jack, and I'll walk you through my code here in a second. And we're going to we're going to consider to use this libnet. I might be building my implementation from scratch again. I don't know. It depends on how much time it's going to take for me to learn this new library, and if it's going to give me what I'm looking for, or if it's going to be faster for me just to type something up in C natively really quick. And so anyway, one of the things that drew me to this, there's a couple things that excited me about this. Number one, it mentions libpcap. It says it provides a portable, low-level network packet writing and handling with libpcap, and you could write some really cool stuff. It also says it does injection of network packets, which I believe injection of network packets is going to allow us to actually put packets out on the wire, not on my, so this is exciting. This is where we're actually starting to do some real like network hacking, not on my computers or my rack behind me, but actually out on the network gear of the world. Does that make sense? We can just put packets out there. If we can put packets out there, we can maybe even learn some stuff and send some information back home. So a lot of this came from one of our viewers slash a buddy of mine who works at Google. He had reminded us of this library called Paketo. Paketo Kairutsu. It was written by a guy named Dan Kaminsky in 2002. So it's old code. I found a copy of it on archive.org and I went ahead and archived the code. This is all Dan's code. This is not my code. So don't think this is my code. This is not my code. This code belongs to Dan. And I believe Dan Kaminsky has since passed away. And so here's his code. And he does some stuff with libnet and libpcap as well. And we think that this paratrace tool here does some similar things to what we're talking about. And let's just go ahead and read about it together. Okay, so it says paratrace traces the path between a client and a server, much like traceroute. So this is very similar to what we want to do, except for we want to not only trace the route, we also want to instrument as well. And I'll talk more about what that means in a moment. But with a major twist. Rather than iterate the TTLs and UDP, ICOMP, or even TCP send packets, paratrace attaches itself to an existing stateful firewall approved TCP flow. So this is what I want to talk about here, is it attaches itself to this TCP connection, statelessly releasing as many TCP keep alive messages as the software estimates the remote host is hop distant. The resultant ICMP time exceed replies are analyzed with their original hop count tattooed in the IPID field, copied into the return packets by so many helpful routers. Through this process, paratrace can trace a route without modulating a single byte of TCP layer 4 and thus delivers fully validated, if occasionally redundant, segments at layer 4. So we're going to be doing some similar things here. I think where he loses me is this ICMP time exceed replies are analyzed. I don't know if we're going to be sending ICMP back. I don't know what the architecture of TCP Jack is going to look like yet. I don't know if I want to assume that there's a server running somewhere. So we're just going to kind of start hacking today, and we're going to learn more and just let the juices flow and see what my little brain comes up with. And again, the whole point is I want to be able to trace a TCP route. I want to know its network hops, not just the client server. I want to know its network hops. Does it touch a switch? Does it touch a firewall? Does it go through any nanning? Does it go through any routing? I want to know as much of that as I can. I also want to be able to hijack a connection. And so one of my goals for TCP Jack is for it to be used in conjunction with Netcat, so that I can just pipe things to it and from it. So I can, like basically go TCP Jack and hijack a TCP stream, and then, pipe some similar like commands that you would pipe Netcat to it. So I can basically like find and establish TCP stream and then like maybe run a reverse shell over it or something. So TCP Jack will be hopefully used for something like that. Anyway, hopefully this explains what I'm thinking. Before I get into the code, I'm going to have a little bit of coffee, and this is your chance. If you have questions, now's the time, because if you ask me questions once I start coding, it's going to end poorly for both of us and for all the other viewers. So, who has questions? Now's a good time. Ask me anything. Ask me about my trip. Ask me about TCP Jack. We got 5 minutes of coffee time, and then I'm going to start coding. You can ask me about the dog. You can ask me about cybersecurity, career advice. You got 5 minutes starting now. We'll start a few minutes after 9. Natty Man has a question from earlier. It says, can I ask a question about connection timeout problem in command you're trying to install packages? Can you recommend a solution? Yeah, try to ask succinctly and I'll try to give you a quick answer. Okay. So let's see what we got. Mouse Me says, what's the highlight of your trip? You went out to the desert, right? Yeah, I did. So I haven't shown people a lot of the trip yet, primarily because I'm trying to kill my ego. But I can show y'all, it looks like we have 2 things I can show you. 1 second. So we'll do this one and we'll do this one. So we can do some quick trip photos. Okay. So I had done some climbing in Red Rocks. So this is a route that a friend of mine and I climbed. It's this hand-cracked dihedral. This is her up at the top. This is me basically looking straight up in the air. And this is us coming up the route here. So looking back down. Let's see, can I zoom out? How does this? There we go. This is us eating lunch. This is another route we did. This is going up the route here. You go up this hand crack and then you traverse across and you go up this crack system over here. So this is, I think that's me. I think this is me actually at this, on the summit looking back down. I was like belaying people up. So we have some other pictures. I don't really know where they are right now, but that's some of them. So this was the warm-up trip, here. And then we went and we did a big Yosemite climb. So I had done some rock climbing in the Yosemite Valley, right across the valley floor from El Cap. If y'all are familiar with El Cap. So this is the wall up close. And this is the cathedral spire, the summit of the cathedral spire. We had climbed right next to that. And let's see. So this is like looking down the route here. So you can see how high off the valley floor we were. It's kind of in the shade here, but that was by design. It was very hot in the valley. So I think this was the highlight of my trip, this route. So we had made our way up to the summit. And when we got to the summit, we were right across the valley from El Cap. We could actually see the summit of El Cap. And then this is like a panorama view of the Yosemite Valley. And that's like the actual summit block there. There we are. And this is the spire from below. So the tip of this is that little spire I just showed you a second ago. This is the route we climbed. These 2 photos are taken from the same spot. So basically looking left and then looking right. And you can see like, you can't describe this stuff to somebody if they haven't been there. So I'm like kind of glossing over it. But yeah, this is the Yosemite Valley. This is a tiny tree growing off of an old burnt dead. It's cool to see life coming out of like a dead tree here. This made me happy. And it was flooding. So these waterfalls were just like the whole valley was just flooded like this while we were there. It was beautiful. You could just see these waterfalls just forming everywhere. Anyway, that's Half Dome, so on and so forth. So anyway, that was the highlight of my trip. More questions. Let's see what we got. Cool. So next question. How's the new home so far? It's really good. We like it here and we're happy. I got a garden planted and I have a rock climbing wall built in the garage now. Did you see a lake on your road trip? I did. I spent some time in the Pyramid Lake Reservation in the Black Rock Desert, which is where Burning Man is hosted. I spent a lot of time there. Why is there a severe lack of dog cam on the stream? I think because he's asleep with my wife right now. Evil Rocket says, which operating system do you use? I run Arch Linux and I run just a regular stock Linux kernel. I don't do anything to my kernel unless I'm working on the kernel, in which case that's a different story. But most of the time when I run, I just run Arch with a regular kernel. Yeah, where's the dog? Let's see. I guess many routers are configured to block ICMP these days, so relying on ICMP to measure things may hit a wall. So PeopleTree brings up a good point, which is like, how do we get traffic back? So we had to solve this problem with BoopKit. And so if you look with BoopKit, we basically came up with multiple strategies to accomplish the same task within the program. So if you see here, if I scroll down, we have, see, it's, where does it say? Boop vectors, right? So these are the different ways you can effectively send a packet to the server to tell it to do the remote command execution. So like number one is it tries to send a send packet with a bad checksum. However, some firewalls will block that. And if that doesn't work, it then tries to send this other packet that is less likely to be blocked by those pieces of network hardware. And we had to do extensive testing and research and reading to figure this out, right? I think number one was blocked by AWS, but number two was blocked by Google. And so like the fact that BoopKit tried both made it just like feel magic and transparent from the user's perspective. So I suspect we'll kind of try to do both. You know, if we send off a trace packet and we don't get any data back, maybe like we send it off a second time, or like we send 2 exploratory packets out and we see which one comes back, kind of thing. That's how InMap does a lot of its work. And so we'll probably do some clever hacks like that, where we like send off some investigative packets to go and probe and see what's out there. And then whichever ones work, we'll like continue to use that strategy for the rest of the runtime duration or something. But it's a good call out. Network hardware is finicky these days, and they take an already ridiculously complicated process and make it even more complicated. Insert says, what do you prefer, more space or time? I mean, space-time is one thing, so that's like asking, what do I prefer, electricity or magnetism? It's the same fucking thing. So I guess in terms of like people, I think I want more time. I'm getting better at working around other people. Getting to the point where I have like people around me every day has been good for my social anxiety and my social problems. And I'm getting better at working around other people. And how many in we? There's 3 of us right now. So far I haven't tried all the basic troubleshooting solutions so far. Okay, we're well over our 5-minute budget. It's time to start coding. So I'm gonna sit down, I'm gonna put on my GitHub hoodie, and we're gonna start coding. All right, let me grab my hoodie. I didn't brush my hair this morning, so it's all over the place. I also haven't washed my hair. Okay. Can y'all hear me okay? This microphone's at a good distance here. I'm assuming this works for everyone. Okay, so we're gonna get into the code. Let's get started. And let's do music levels. I'm gonna bring the music, what do you think, just down, just one tick? We're at, it was at 100, I brought it down to 90. In fact, let's do this. Let's bring it down to 60 and we'll turn it up here. We think minus 30 decibels is right where we want it. Okay, cool. And we're going to get my windows moved over. And we'll bring those up as we need them. And I'll share my screen in just a second. I'll make sure we're like, we got everything ready to go. Source, TCP. All right, let's do this. So if you're new here, welcome. If you've been here before, welcome back. If you don't know what you are, welcome to the party. The repo that we'll be working out of is here on GitHub, called TCP Jack. We spent a lot of time last time trying to come up with a name. So right now we have a very straightforward C layout I want to get a little bit better. I'm debating if I actually want to start using the configure file or not. I suspect we will moving forward, but for now this is fine. It's got a make file, and we actually need to change my header out here at some point. It looks, in fact, we'll probably do that now, but I'll walk you through the code first and then we'll change the header. So it's a very straightforward make file. For right now, it's very simple. It'll grow in complexity as we grow, I'm sure. And it basically just compiles this target here using Clang. And we've got a couple of libraries that we're vendoring, libnet and libpcab. If you're not familiar with how C works, basically the include directory is like your public API. So I try to keep this looking quite beautiful. So what I try to do is I try to put these big doc blocks on top of every one of my structures and every one of my functions, so it at least looks pretty and so people can read it and understand what I'm doing. When I write C, I want it to be very readable. You'll see a lot of people who will do like, they'll have like, you know, struct, you know, like ZCL T00T, right? And this is like a type that they use, and that doesn't really tell you what it is or whatever. I try not to do that. I try to actually name things like what they are, and I understand this goes against like ANSI best practices, but you know what? It's my fucking show and it's my code, so fuck off if you don't like it. So it's readable, and you should be able to intuit a lot. So it should almost look like I'm writing like Python or PHP or, you know, C# or C++ or something, if you're familiar with those languages. And so it will be written in regular old C, but hopefully it doesn't look like it's written in regular old C, if that makes sense. So the main function is here in TCP Jack.c. This is a very classic Nova like entry point here, and maybe we'll like, you know, spruce this up a little bit like we did with BoopKit and make it look all pretty and, you know, use ASCII art and stuff in the future. And we have this little CLI setup function that basically does our argument parsing, and we have these little flags we can hook into. Right now we only have two flags. We have -H and -L, and if you call -L, it will basically do a TCP. It calls this list function, and then it calls print list, and I can show you all right where I left off. So basically we can call make, and then we can just run the binary when it's done, which is TCP Jack. And you'll see that when you run the binary by itself, it just echoes out this little help section here. And you can see we can do -L for list. And this is where I left off. So what I want to do is I want to list all established TCP connections on my system. Okay, and so what we have here is, this is just some debug. Don't look too much into this. This is just where I left off coding. This isn't like a finished thing. This is all going to change. So it's a group of 3 lines. We have this local address, which this is an IP address that just needs to be formatted differently. And this state TCP established is what we're looking for. So you're probably wondering where I'm getting this information from. So without going into a huge diatribe about how the kernel works and why I have feelings about the proc file system, we're just going to gloss over all of that, and we're just going to say I'm reading from proc. We've had enough of those proc rants for one lifetime here on Twitch, so we'll just gloss over it. So here in this list.c is where I actually do my dirty work. So I read from this file called procnet TCP. Who here is familiar with procnet TCP? I think I can pipe this to less. So procnet TCP, I'm not. So let's see, can I? There we go. I know this is kind of small, but just bear with me on this one. I just want to get this all on the screen. And yeah, this is about the best formatting we're going to get for now. So basically, this first row in the file is a header, and then this is all of this is the system state. So these are all of our connections, and it doesn't look like very much right now. Okay, and that's because this information is in its raw form. you know, the UID is probably the most familiar one, and maybe even the inode looks a little familiar as well. But this is basically the network stack in real time. And the way that proc works, when you read something from the proc file system in Linux, it basically reads from kernel memory in the moment. So we say at runtime. We'll say it reads from proc at runtime. So basically it comes in and it says, show me everything in the kernel now. And then it gets everything out of the kernel, and then it just spits it out in the form of a file in front of you. And all of that is just software at the end of the day. So we call it a virtual file system, but we basically just synthesize a file. It's not a real file that exists in blocks on a disk. It's this imaginary, this make-believe file called a proc file. And the proc file is just like a format that the kernel gives you as a user so that you can see what's going on inside of the kernel. That's it. That's all the proc file system is. And so if you want to know how I found out about this, well, one, I've just kind of known about it for a long time, but two, if you go to procnet TCP, there's a couple of resources we can use on the topic. My search isn't working. Let's see, there we go. So let's see. So here's one we can use. And I think there's probably more. So here's one we can use. So this kind of breaks down like the connection state, the remote TCP port number, the remote TCP IPv4 address, the number of the entry, and so forth. So if you look, we can actually pull this information out of this file. So all that this file is it's just a list of everything on the system. So who here is familiar with the command netstat? Who here knows about netstat? Who here has used netstat? Maybe a more important question: who here has heard of netstat and thinks netstat is stupid? That's actually a good question. Who's pissed off at netstat? So netstat, SS is the modern replacement of netstat. SS is a good tool, but it doesn't do everything netstat can do. SS is another good tool we can look at as well. But all of these are useful tools, and we're going to talk about how they work and what they do. I've heard of it. I tend to use SS now. So this is like IP and ifconfig. I like both for different reasons. But anyway, we can actually demonstrate the same thing with either netstat or SS. But if we just do netstat AN, so like if actually we'll do netstat help. So A for all, where's A? So I usually just do A for all, okay? And this will show us all connections. And then N for numeric, and that basically says give us the IP address instead of the host name. So these are kind of my favorite ones to use here. And there's other things you can do here. But if we do netstat AN, you'll see we'll get a list. And if you look on the left, you'll see we have these, like, I'm looking at this column here, this Unix column. We're gonna go find the TCPs. They're up here somewhere. We have a lot of Unix domain sockets, it looks like. Oh my God. Here we go. So maybe I'll just do this. So we'll do grep-i TCP. There we go. So here you can see these TCP connections, okay? And so see these ones where they're in socket state established? So this is where I'm gonna connect some dots for folks, okay? We're gonna go quick, so just bear with me. This record, this single horizontal line is just a single record from the kernel, right? It's one TCP connection. So we can get the information from that from procnet TCP. So if we were to open up a second terminal, we would actually be able to correlate one of these records in here, one of this gobbledygook here, all of these zeros and ones and hex code that doesn't make any sense. One of these corresponds to one of these. And this is just the pretty version of it. Instead of printing, see this column here, ST, so this value, this value, this value. Instead of printing this hex code, it's actually printing the English. It's called an enum. It's printing the English version of it. So that's where we get this TCP established from. Okay, so how we do that in C is we actually use the same header file that Linux uses. So in this case, we're using good old netinet tcp.h. If you've ever done any TCP work before, you're probably familiar with this tcp.h as well as Linux/tcp.h. Those are two of my favorites. There's a bunch of tcp.h's. There's too many of them, if you ask me. Anyway, if you look down here, this TCP established is, if we go look it up, it's this enum here. And you can see here, the way that enums in C work is it basically provides a numerical value, and in the case of GCC, it's an unsigned integer, but it's an unsigned integer value of an English term. So 1 is equal to TCP established, 2 is going to be equal to TCP send, and then send receive and fin wait and so on and so forth. And if you look, all of these will correspond to, let's go find a good, I love a good ASCII diagram. Let's see if we can't find one. I want data tracker. I want, here we go, IEFT. This is the pretty one. Let's go find the very classic TCP handshake here. Here it is. This is the good one. This is my favorite diagram in ASCII ever. So here you can see we have closed, we have listen, we have send received, we have send sent, we have established. And if we go and we look at our enums, these should all start to look familiar. So this is how TCP works. Okay. So all I'm doing in my code is I'm saying we're pulling this ST right here, this ST, and I basically, here on line 42 is where I get it from. I say if state is equal to TCP established, I just debug some information, and remember when we ran my command a moment ago and it printed off those three things? This is what it printed. So what we have here is reading the socket state. So this is the same information that netstat or SS would read if either of them were reading. We're reading this information directly out of the proc file using this fscanf function. And this formatting here corresponds to one of these lines. So basically what's happening is if I was to connect all the dots, I read every file from procnet TCP, which means it's coming directly out of the kernel. I use this format of this line, and I basically print, or I scan all of these variables here off of this formatted line. So if you look, we have a string, and then a space, and then a string, and then a space, and then a string, and then a space, and then a hex number. And if you look here, we have a string, and then a space, and then a string, and a space, and then a string, and a space, and then a hex number. And here it is, and that's our socket state. 0A, 0A, and then here's 0, 1. So this is an established TCP connection. So on my computer, the moment I read from the kernel, that is an established TCP connection. So once we have the established TCP connection, we can look at its inode, which is exciting. There's a lot of cool stuff we can do. And one of the things we're going to be trying to do today is we're going to be trying to hijack one of these existing connections. And so if you know enough about how the kernel works, you should just be able to kind of rip the shit apart, and it's all fucking funny money at the end of the day anyway. So nothing on a computer is real. It's all fucking Play-Doh. And so we'll just try to rebuild something and see how good of a job we can do. So anyway, OX Clayhack says me loves capturing passwords from those SYN packets. Yeah, I don't think SYN packets usually carry a payload. I think, an established connection is usually the one you want to look at if you want to do any like data packet snooping. But yeah, you can find a lot, and everything I just showed you, everything about ProcNet, TCP, and TCP connections in general, this is all well known. This has been well understood since the 90s. You know, TCP dump, Wireshark, all of these tools take full advantage of this type of work here. So anyway, what we're gonna try to do now is, now that we've basically been able to list our TCP connections, we're going to go and we're going to try to find one, and then we're going to try to hijack onto it. But we have a lot of work to do to get there. So I'm going to start to go into my coding headspace, even deeper into my coding headspace now. And so if you haven't seen one of my shows before, I do talk, but I also kind of like, my full autistic brain comes out at some point, and I just kind of turn into a zombie. So, you know, buckle up. It's going to get really boring. Okay. Okay, so we want to get rid of this for now, so we can comment all of this out. We know we found a valid TCP connection here. And let's actually put a record in our TCP list. So line num is 0. And TCP cons numcon. Here we go. So let's do this. TCP list dot numcons is equal to line num, I believe. No, that's not going to work. So we're going to create a different. Cool. So this will be line number in the proc file, and this is going to be number. We'll say this is actually count of TCP established connection. There we go. Okay, so we have 2 counters here, and so line num will increment every time, and then here we're going to do numcons. Didn't I call it numcons? Why is my... There it is, numcons plus plus. And then right before we comment this out, we'll close our stream here. And then right here, we're going to do TCP list numcons equal to numcons. Do a little memory magic. And there we go. Okay. So now that we found a valid TCP connection, let's hack in here. Let's figure out what all we want to share. So I'm sure we want the inode. So let's grab the inode for sure. And I bet we also want the port. I suspect we're going to have to change this car32, because if we look here, I'm grabbing this whole value and we need to actually separate it into 2. So remote and local. So let's break this apart. So what's a good data type to use for IP addresses in C? I think I've used car in the past. Let's check good old inet to C data type IP address. Is it an integer? So there's inet into A. I know there's adder T, and there's like actual proper types for this. I don't know if I want to use the actual. UN64T, please, says Nightfall. That sounds right. Is that what inet uses? Let's go see. So uint 64T. So this will be local struct in adder provided by net. But I don't think we can scan onto that. We need a primitive type to scan onto. Then we can use the INET library to get it into the in adder type. I'm gonna go with uint64t for now. So we'll call this local adder IPv4. And then I think we're gonna do an int local adder port. I think we want to do that. I think we want to do that. Actually, IPv6 needs 128 bits. I don't think we have IPv6 in here, do we? Let's go see. I think there's procnet TCP6. There's a different file for IPv6, which brings up a whole other set of concerns. We'll worry about IPv6 later. Spoken like a proper American. Fuck IPv6. Let's go. Let's go. Oh shit. Sorry. For those of you who don't know, IPv6 is a huge point of contention. Won't uint64t take too much? IPv4 was 32 bits, no? Yeah. Let's do uint32. Well, I actually think we can actually just do, yeah, I think we want yeah, let's do this. uint32. And this is remote adder. And this is remote adder. There we go. That should do it. And so now it's going to be this and this. And so then it's basically going to be local adder. And then this is a pointer. And then we have another pointer, local adder port. And then we're gonna we'll move you down for good measure. We will do a pointer to remote adder IPv4 and a pointer to remote adder port combo. There we go. That looks nice and tidy. And so we should have these now. And we can actually grab ARPA inet.h, I believe. It's ARPA, right? ARPA inet.h. And I think here we can do the IP translation. So we will do a struct. What did we say? It's in adder, right? In adder, and we'll call this IP. And we will basically say IP dot source adder is equal to local. We'll call this local IP. Local IP. Sorry, I didn't change it here as well. IP source adder is equal to local adder IPv4. And we will then say par, or actually let's just have a type, a proper type in our struct. I think that's what we want to do, actually. The more I think about it. Should port be unsigned? Not if it's 32-bit. Yeah, I think ports can just be a regular old int. I'm pretty sure they can be. We'll give it a jingle and see. let's just print this out for right now. So let's grab this. And before we get too far, let's just make sure we're kind of in like the right department here. And so this is remote adder IPv4. And so we can do, we'll get this print and we can actually commandeer both of these. So this is now, what is it? It's into A, right? Into A. So this is inet into A, returns a car pointer. And so then I think we basically do local adder, local IP here, like such. And then I think we do inet into A, remote IP here. And then I think we want to do port, and then this will just be our local adder port, and then this will be our remote adder port. There you go, and state TCP established. And I bet we can even do, like, just for good measure, just to kind of like tidy things up a little bit, we'll put like a little dash there. Okay, let's give it a jingle, shall we? Let's give it a go and see what we get. TCP Jack, so make and TCP Jack list. All right, no results. Good job. Are you only getting outbound packages? Otherwise, source address isn't necessarily on your local addresses. No. I think my intuition just tells me grab what I can because we might need it later for some other reason. And I guess in theory, if we could multiplex a TCP connection, that would just be way more awesome. Although I suspect will require way more work. Good question though. So let's see. Hello, hey B-Fred, how's it going? So let's see, we have our local IP. Why did this not work? We didn't get anything out? If, I guess maybe state is no longer working for some reason. We're probably not scanning correctly anymore. So let's see. So %X instead of D for scanf for IP and port. Yeah. So that was X. Do we want X for both IP and port? I mean, we can give it a go. There we go. Look at that. All right, so we have a local address. This is my computer's IP address, so that looks right. Port 47342, that's an ephemeral port. And remote address on 443. This has got to be, let's go see what this is. This has got to be some website I have pulled up. Closed captions for stream site. It's my stream. Twitch AWS extension challenge. I love doing this type of stuff. You find so much cool shit going on. I don't like, let's find, this is another 443. I could do this all day. I could just sit here and just tinker with computers all day, you guys. Let's see what this one is. This is on 443. It may not all of these are gonna have their server configured to, God, who knows what website this is? We could go look it up, but it doesn't matter. Anyway, it appears to be working is the point that we're trying to get to here. So here are all these established TCP connections. Oh, and look, we have a beautiful segfault here at the end. I think it's because we're not allocating the memory down here as expected. We're looping over numcons, and we haven't actually put anything in there. So that segfault is nothing to worry about for right now. Okay, so let's comment this out because we'll use these here in a moment, but we got to build a library here, so we're gonna have to do some memory management. I think I want to get rid of this, and I want to actually copy this here. Here we go. And sorry, I just want to clean this up and get this into my code base. I don't know why it wants to format everything like this, but there we go. Okay. So I think we can actually get rid of that. I think we want this here in my code for reference, and then we'll put a doc block above this, even though we have one in the header, and this will return TCP list, and I'll say implementation for the list function. Currently only returns connections in TCP established state. Oh, here, sorry. That's probably easier for you if I zoom in. In TCP established state. And we could probably make this more dynamic later, but for now this is fine. Okay, we'll get rid of all of this. And we can get rid of, we'll move this down here. And we'll debug that in a moment. So now what we're going to do is we're going to start mapping things onto TCP list cons. So I've created this struct in our header file here. Where is it at? This one. And so I used name just as like an example. But I think what we're going to actually want is we're going to want to put, let's go see. Let's go back and forth. Which of these fields are we going to want to track? I think we want inode for sure. Which, let's make sure integer is the right type for an inode. Let's go check the man page. I think it's got to be an integer. So here's the source code from 6.3.2. So inode. There's an inode hash table. It's got to be an int. I know an inode itself is a data structure. I'm wondering the inode number is what we're wondering about. Unsigned long st inode. Let's see. On a 32-bit non-LFS stat call, glibc will generate an E overflow error if it went to the target. Use 32-bit counter here to attempt to avoid that. Okay. Cool. I can't seem to access your book's website. Is it? Yeah, here you go. It's down for right now. I'm gonna keep it offline for a few more weeks. I'm sorry. Okay. So we think it's an unsigned long. Inode number. I think it's an unsigned long. It's a 64-bit inode number. It's I know. So let's see. I think it's an I'm doing unsigned log. Unsigned log. From ASM generic stat.h. It's an unsigned long, ST inode, file serial number. Good call. Cool. That's for 32-bit machine. Scroll down for 64. Okay. Cool. Well, I guess, I mean, I don't know. This apparently has caused problems with NFS servers, so we'll go with long and just assume the world doesn't run 32-bit machines anymore. We'll put in support for 32-bit later. I don't care. I don't give a fuck. I don't give a fuck about you. I'm assuming there was some, we can go look and see. I'm assuming there was some pound defined I missed. What was it? Stat.h? Define stat. If bits per long 64 define, here it is. Unsigned long, here it is. This is only used, struct 64 and glib only used for 32-bit. This is not equal 64-bit. This is 64-bit. This is 32-bit. Or defined arch want stat 64. Bits per long equals 64. Bits per long is not equal to 64. So if bits per long is 32, so this is 32-bit. Only used for 32-bit, okay. Alright, cool. Cool. Alright, so we have our inode, which we know is an unsigned long. So let's go get that in our API. So this API will probably end up using this in Rust at some point. So we want it to just kind of only contain the things we actually need. It'll be an abstraction to some extent. So We have an unsigned long, which is our inode. We also want to get our, let's include, ARPA, inet.h. So we will have our, do we want to call it source or destination? Local adder is an in adder. Where do we get the IPA, the adder, the in adder type from? Is it just not? Struct in adder, local adder. And then we said for ports, it's int, local port, struct in adder, remote adder, and then we have int remote port. And we want to, this is why I like Saturn adder, is because it's a lot easier to abbreviate everything. Okay, so I think that looks good for our API. We have inode, we have a good old-fashioned in adder for our remote and local addresses. Is there anything else we want that I'm not getting today? These RX and TX queues are interesting values. A lot of my work that I did the other day with Nginx is relevant to these two queues. That's the work I do at GitHub all the time. I'm always looking at these stupid fucking queues. Anyway, what else do we have? We have local adder, remote adder, queues, retransmit, maybe the user ID? Sure, I mean, why not? We might as well. It's an int. Let's just grab it. And we will make this a UID type there. And then inode now needs to be an X. So, what's unsigned long format? Capital D? An L for long? Unsigned long format. LLU. Cool. And UID is here. Okay, sounds good to me. Okay. And let's get our UID into the API. Save format and make format. Why did this not auto format? That TCP list size defined and how it is used is exactly why I don't like writing C. The fact that we have to use this as basically a well understood int value that we can use to populate memory size. It's basically memory management. Is that why you don't like it? Because it doesn't dynamically do everything for us. 1 second. Yeah, it gives a hard limit for the list. Yeah, exactly. Exactly. I know. But so the problem is I just like being able to just use native types though. Like when I was like, oh, we'll just look up the enum value and it's just right there. Like it just makes it kind of nice. Only for the reason that making its dynamic is too much work. It's always too much more work. Anytime you start dealing with dynamic arrays and Cs, I'm always like, this was a bad idea. I should have just used 1024. It's my good luck number. Writing C. It's my good luck number. Okay, cool. So if it's established, we'll do numcon. So basically we'll build our API here. Where remote port is defined, you want in instead of int in the API. Let's see. Thank you. And I guess we should just spell it. Okay, so here's what we'll do. Grab this, we'll uncomment it. We'll take rid of our name. And we'll initialize a new struct. So inode going to be equal to inode. Local adder is going to be equal to local adder IPv4. Local port is going to be equal to local adder port. Remote adder is remote adder IPv4. And remote port is equal to remote adder port. And UID is equal to UID. And why is this yelling at me? This value is never used. Got it. Okay. So why is this thing not auto-formatting? Isn't it, what is it called? Watcher? File system watcher? Who wants to figure out how to do C auto formatting in C Lion? Yeah, I have no idea. And make format doesn't work. I think maybe because there it goes. It did it. Include .h and source .c. And we'll add them as needed. Okay, so let's .c. Okay. So here we have our TCP con. And so basically what we do now is we're going to say TCP list. TCP list. And this is numcons before we increment. So numcons is defined here. And that's 0, so it's in our while loop, and we only increment numcons after we've done this. Okay, so TCP list numcons is equal to this. I guess I'll do this. Or maybe, actually, can I just make this literal and get rid of this? Why can I not do that? Go. Thank you for the follow, everyone. Also, how's everybody doing? I hope y'all are enjoying Sunday morning. It's supposed to be 2 M's in NumCon. I mean, I don't know, maybe. There's 1 there. There you go. Enjoying Rust more than more. I do love Rust. I think Rust is my new favorite language, honestly. I do love Rust. It's like wholesome. It's like good for the whole family. It's like going to Sears. Like the Brady Bunch. Okay, so let's see. TCP list numcons is equal to numcons. After we've incremented here at the end, we add our con here. So for every con, we have that. And then we will now put together some better printing. So let's do this. So basically, for every connection, we want a single row. So the first thing we will do is we will do printf. This will be our local address. So actually, we're just going to say TCP established. And then what's the function that allows you to do like the pretty tabbing so all the columns line up? I forget the C function for that. I've used it before. I always forget how to do it though. Cool. So we will do local address. So this will be %. How do you print strings? That's local address. Local port connecting to remote address, remote port, and then the inode we'll put in brackets like this. And an inode is an unsigned long, so LLU. And what else did we add in the user ID? And we won't print the user ID right now. That's probably a good formatting string. What do y'all think? I think that's good. I think that's a good starting point. So let's get everything in there. Okay, so the first one is going to be TCP list dot cons I dot local adder. Okay, and this is, we'll bring you down, and so you're going to be in good old inet into A, and we'll put you there. Okay, and then our port will be, so do we want to pull this out into its own variable, or do we want to do the TCP list cons I every time? Let's pull it out into its own variable. like this. They are, but the fact that Chris opted out of fixed size array suggests that they are not easy, says Le3. Rust is a better C? Yeah. I do love Rust. I think like I said, I think Rust is my favorite language. And then inode. I think that's it. Ah, what did I, what, okay, I thought I hit backspace, but I guess I double hit a key. Okay, and so then we want a new line here. Who thinks it's gonna work? Let's give it a jingle and see. There we go. There's our established TCP connections at runtime. Make format, get status. Let's run our make command again. There we go. Get status, get add, get commit s, sign m. We'll say commit from stream. Working list of TCP established connections from Profit. Yay, we committed code on stream, you guys. It's been like 3 months since I've done this shit. Oh, yeah. Feels good to be back. It feels good to be back. Cool. All right, so we got some code written. It's not good code, but it's a starting point. It's a starting point. It's great to have you back. It feels good to be back. It feels good to be back. Okay, so print list. We'll say basic, simple contain function for the TCP list struct. Oh, it's not a type. There you go. Simple standard out printing function. There you go. Cool. Okay, so we now have some good plumbing in place to get established TCP connections out of proc up into oh, that's the auto formatter, isn't it? This is the auto formatter. Yeah. Okay, we got to fix my headers because the auto formatter is gonna fuck it all up. So let's just nuke this whole thing and let's build a nice new header. I also need to get my new email address online, so let's do that really quick. This is like something I need to do. It's been like irking me for a while. So let's try this. Make sure I have the domains. We're gonna get my email address, my new email address working. I have a new email. I'm looking in the Google. Here we go, manage domains. We're gonna add a domain. We're gonna add chrisnova.net. So I own chrisnova.dev and I also own chrisnova.net. Which one do we want to use? I think we want to use chrisnova.net. That's my blog. Cool, so we have to verify my domain. And it should be in here. Is it not? So let's see, hosted zones. chrisnova.net, there it is. Okay, so we're gonna configure this with my text record from Google. So just add a text record here. So I think we just edit this and we just do that basically. And then I go back to Google, which you don't see, but I have this other thing pulled up here, this verified domain thing with Google. If you've done it before, you know what I'm doing. If you haven't, it doesn't matter. We can just hang out while I do stupid DNS stuff. Amazon has way too much power. Okay, so let's see. It's still verifying. So let's get some good ASCII art together while we ASCII text. So I used to just do Nova like this. Which one looks cool, you guys? I usually do like the dripping black, this one. I usually do like one of these. Like I think this is the go-to here I usually do. I don't know. Who has opinions on this? This will be with me for a while. Who has opinions? I think they all look pretty dumb. This is what I do. I scroll through all of them and I get to the bottom and I'm like, I think I'll just pick the boring one. That's easiest to read. It's easiest on the eyes. The first looks cool. So we'll select and copy this one. Actually, you know what? We can maybe try to mix it up. I always go to this Pator JK site. Is there another one? I wonder if there's like another. I know there's like Figly, or what's the command line tool. So let's try this. Let's try Chris Nova. Test all fonts. Ooh, see, we have some new ones here. Some of these look familiar. I feel like that just renders really horribly in the browser. Here we go. Super boring. Oh, that's going to cause problems. What do we think of that? Let's see, is my domain verified yet? Nope, let's refresh and try again. Less than a minute remaining, it says. Let's close it and try again. Verify domain. Okay, it's still spinning. So maybe Google's just having bad weather today. Okay, so, and then I think we want stars all the way around. Am I right? And then we want this to go all the way over to this line here. This. Cool, and then we'll do spaces all the way over. And then we'll get the insert key out here in a moment. And we'll add my email and stuff, and this will just kind of be my new header I use for all of my stupid open source projects that never get finished. And that's okay, because you guys know my philosophy. It's not about finishing the project. It's about learning and the joy of coding. Looks nice. Okay, so go. Nice and centered. And we'll do one more. Start here. Yay, pretty printing. We're unable to verify your domain, so let's go check my... Let's close this, and let's go check my thing. So copy. Add a text record is... A text record is just a value. How to add it. Copy your text code. And put it in text. For simple routing. Okay, so we have text here. Oh, I added it to the wrong one, that's why. So let's remove it here. That's at proto. I don't know what that is. We don't want that. We want regular old text fit. So it'll just be this, create record. There you go. That should work really quickly. Oh. So now we have to figure out what my email address is going to be. So it's basically going to be, so we can do chrisnova@chrisnova.net, which I kind of hate that. I also kind of hate the me at. So we can definitely, we could do like, info, admin, user, why not just Chris at? This is something I don't tell a lot of people. I actually hate when people call me Chris. And actually, I really hate when people call me Chris. I would prefer if people could just call me Nova, but I don't tell a lot of people that because you're not my family. But like, everybody who knows me calls me Nova. And it's kind of a quick way of me of just determining like who actually knows me in real life versus who knows me from the internet. Not that there's anything wrong with either. It just like helps me kind of know how much of a guard I need to keep up because people love to attack me. So anyway, you need info admin, host master, domain master, postmaster, etc., etc. Yeah, I think let's do, I just don't want to use the word master. I think actually admin@chrisnova.net. I don't hate that. I really don't. It's either that or it's root@chrisnova.net. I'm gonna go with admin. We're gonna go with admin at chrisnova.net. Cool. +1 for admin. Awesome. I love it. Cool. So activate Gmail, set up MX records. One second. So here we need to add these 4 MX servers. Where are you at? Do we have MX in here? I don't see MX, so let's create them now. And there you go. And now I can do users, home, users. We'll take my good username and we'll add, who wants to send me an email? Let's make sure this works. Add alternate emails. We said admin at chrisnova.net. chrisnova at chrisnova.net, and we'll say chris at, just because I know people are going to use this, chrisnova.net, and we'll do Nova. Oh, who wants to shoot an email over to admin? Somebody shoot an email to admin from another thing. Oh, all right. Makes sense. I do not have a catch-all address because I get too much email as it is. My wife, however, she definitely is a big fan of the catch-all black hole email address strategy. You should talk to her about it. She's much better at that stuff than I am. Cool. I'm not gonna lie, I hate it. I hate it. I'm sorry. I know y'all came to write C, and we're not gonna write C, and I'm okay with that. That looks better. Closer, warmer. And now we're doing ASCII headers, but you know what? This is my show. So you get to watch me do whatever I'm gonna do. Actually like that a lot better. I think one more here. Okay. I'm sending from a Gmail address. Let me make sure I've got it. I'm logged in as there and more spam maybe. Okay. I guess I can try to email. So admin@chrisnova.net. Let's see. I'll send one to myself. Okay, so I think that's good for now. I know that was a very long journey to get here. But it was worth it. Hashtag worth it. It's gonna look a lot better on GitHub too, and the auto formatter should hopefully play nice with it. Let's see. That'll be the real question. Hey, the auto formatter didn't touch it. Perfect, but it did format my code. Perfect, this is exactly what we want. Awesome. Yay, pretty code. Okay, cool. So let's go clean up the actual source code. So we have our numcons, our print list, so on and so forth. Let's run it again, and we will make and TCP Jack, TCP Jack.l. And there you go. And we'll get status, git add, git commit, SSM, better improvements with new email, git push origin name. Why is the project a fork? Because I forked one of my actually originally started it in Rust, and then we decided to move it to C. But basically I have like a starter repo that I use for my projects. Admin didn't work either. FYI. Oh, okay, good to know. Oh, it did admin@nivenly.com for some reason. Let's do admin@chrisnova.net. Okay, that was on me. That was a configuration issue on my end. It should work now. Let me try again. Test 2. All right, I sent a second test. Reason from switching from Rust to C. Mostly just because I knew that I was going to be dealing with a lot of Linux native libraries. For example, inet.h and tcp.h. And I also suspected that we were going to be dealing with a lot of file descriptor things in Linux, and so I think the more I just dug into it, the more I was just like, I'll just write it in C because it's just going to be faster and more fun. Also, I've been writing a lot of Rust at work. I have this new project I started at GitHub. I hope to open source it one day, maybe this quarter. I have like so this is actually exciting. Can I brag about my work at GitHub for a second? Is that like a thing I can do? Can we talk about my day job for like 5 minutes? I hope I'll be able to open source this thing at work. The only reason we haven't open sourced it isn't like because we can't. It's just because I haven't had time to, because I wanted to like do it the right way. So the only thing standing in our way is me at this point. It's not like, you know, my boss didn't tell me no or anything like that. So basically one of the things I've personally tried to do at work this year is like, this is going to sound ridiculous. Who here has seen GitHub in Hacker News in the past, like, couple of years? I know there was a big outage a couple days ago, or I think it was last week or the week before. I'm trying to like make it stop reading Hacker News years ago. I guess what I'm really trying to ask is like, who here has seen any like news around GitHub like availability recently? Anyway, one of the things I basically did is I said, you know, as a principal engineer over our entire platform, I want to make this like my thing. So GitHub going down, like starting effective immediately is like, that's like my department. It's not like I don't manage people, but like, meaning like that's like my area of focus, if that makes sense. And so anyway, one of the things I'm doing is I started like a formal performance engineering team at work. And so like, I think it's gonna like turn into an actual like thing. Like we're gonna hire perf engineers if we ever get budget again. And like, that'll be cool. And so I get to do like real runtime. I get to use my kernel specialty at work, which is exciting because I get to like use what I'm good at. And anyway, one of the things I hope we get to do is do some really cool low-level Rust work. And I started this project at GitHub that I hope we get to use for some performance engineering work. And one day I want to open source it. And it's like been cool to like, I kind of, you know, concocted a lot of this from thin air. So it's like exciting to feel like I like actually been able to do stuff at work again. Yeah, there was one slightly larger outage just recently. Yeah, and you know, we wrote a really good blog on it, and like I got to watch the whole. I was actually rock climbing in Yosemite when the outage happened, which more on that later. But yeah, there's a lot of hard problems we're solving. Like I'm not gonna lie. Like there's, you know, running the world's largest Git system is not trivial work, and there's a lot that goes into it. So anyway, I digress. So here is my shitty C code that I'm sure OpenAI will be able to come and write better than me in the future. This is another reason I want to write C code. I don't think anybody's doing this anymore. So this will be like the one thing I have that artificial intelligence can't steal. Is like, I can reason about Linux in ways that you can't because it just doesn't fucking exist for you to learn from. Bruh. So that's cool. And so anyway, so we have our list. So now the question is, let's try to actually figure out how we're going to instrument and hijack a TCP connection. So we're able to list them. So if we run our TCP Jack, I think we basically need a way to pass in an identifier for each connection that we want to hijack. So I think the inode is going to be the, you think even specialized LLM like Copilot couldn't replace our work? I mean, I think it will, I think there's always going to be room for humans. I have no doubt in my mind there. I think that it will make a lot of exercises in computer science more trivial, which is cool, but like I still don't ever think we're gonna lose like lots of jobs like the ones we have today. As much as I think we'll free them up for other things. So anyway, and also LLMs, like it's just a language model. Like there's no LLM who's going to be able to do like the same thing like me and a small group of even interns could do, right? Do you try Copilot? I mean, I get enough Copilot on the other end of things. I don't run it locally because I haven't sat down and actually figured it out, and because like my software coding is very much like the joy of coding, right? Like I'm here on Twitch on Sunday because this is fun for me. Like actually writing code is fun for me. So it's just like the same reason that I don't like do machine learning on the weekends. It's just 'cause it's just like not what I'm into right now. Anyway, so I think we want to use the inode as our identifier. So I think the syntax would basically look like this. So we would basically do like TCP Jack and then the inode, which would be the TCP connection. And there's going to be a bunch. We'll be able to do interface and port, and like we'll be able to like add a lot to be able to figure out how we want to instrument a connection. If that makes sense. But I think this is probably the most straightforward. Let's see. Is there a library to open up an inode by number in C? Open file by inode. Here we go. Because they would in a loophole and access control rules. Can a file be retrieved by its inode? Cockpit a file descriptor. So basically, if you try to open up a file by its inode directly, you are usually bypassing the pseudo file system. Ferdinand Selmer, I got your email. Whoever you are, thank you. So I guess that's like a loophole in the kernel if people consider to patch it. I have totally seen makeup classes that don't exist and test on certain things. Sure. All right, so folks are still talking about LLMs in the chat, and that's fine. So the other thing we could do is we could do TCP Jack, like, I think I want to do inode. I think that's going to be the thing that we want to do. I think that's it. And then we'll be able to find the inode from... You can use debugfs. We got to be able to find... Oh, here we go. So let's try this. So let's do find inum this. Okay, so let's do TCP Jack L. Let's grab, because I have no idea how long these are going for. Oh, also this looks like we have a bug because our source and our remote is the same IP address. I bet we have a bug. Let's go see. I bet it's in list.c. Print. This is local adder, remote adder. And then I bet here, remote adder, remote, local adder, local adder, local adder. How are these the same? Because I remember we were getting like public IPs a little bit ago. Am I right? There's localhost again. Why does this look strange now? This is SL XX local adder port remote adder port XX, and then we basically say local IP remote IP. And we say local adder is local adder. Ah. This is it. This is why. Local adder is local IP. remote adder is remote IP. That should do it. There's the local host. Why does it still think it looks like the remote IP is fucked? That rocknet TCP. The remote IP here. Let's go look at this one. Local address, remote address. Yeah, see, we're getting all kinds of different values here. See, we should be getting different values. Something's wrong. There's a bug in here. And I aim to find it. Is our port giving us an off by 1 error? I guess if it was giving us an off by 1 error, it wouldn't be marshalling as 10.0.0.100. And where's localhost? See, this one also goes to localhost. This also makes me think. So the ports change, but local remote stays the same. That's ST there. What's unsigned int? %I. So that's hexadecimal and that's hexadecimal. Your %I or unsigned int, and then TXQ and RXQ is this. So that's 1, 2, 3, 4, 5, 6, 7, 8. So we're gonna do XX for that. So we're gonna do X for that. That was TXQ and RXQ. And then TR TMWin is int TR int TMWin. Retransmit is also a hex. And then UID is an int. Okay. And then timeout is a hex. And then inode is a U. So let's just see how this fares. This looks better, but I still don't see like remote adders. Why is the remote adder still getting? Why is our remote adder still pointing to my local IP address. I guess maybe let's try this. So printf %s new line. inet into a remote IP. Just curious. Just curious. Yeah, see? Something's fucked, you guys. Remote adder is remote IP. There's something's going wrong in this translation to this API. Is it because these are out of order? I bet it's because these are out of order. Because it's C. Let's go see. So here's what we have in the API. So I noticed first, okay, local adder, local port, remote adder, remote port UID. Okay, so the order is right. I know, it's because inet into A. You think that our print function is doing something with inet into A? Let's go see. Returns address to a static buffer. So you think it's just printing the local address twice? You call it twice. I see. So what you're saying is we need to do our local adder C is equal to inet into A on local adder overwrites the buffer. Makes sense. Remote adder C inet into A con remote adder. And then here we basically do local adder C remote adder C. This won't help. This is 2 independent function calls now. This should help. Both cases will return the same address. Yeah, but they work on one buffer. So how do we clear the buffer then? inet into A does this so you don't have to do a free every single time you call it. If you want your output to look the way you want, you can do this. I'm confused. I found a Stack Overflow point. You either need to copy the result somewhere else. Or print the first address, then do the second and print the second address. I see what you're saying. I see what you're saying. So let's just do this then. Hello, beautiful people. And we'll say, actually, we'll do this here on local port. So we can take out this now. This. Got it. Thanks for reading the man page. Good find. Good bug. You should feel good about that one. That was a good one. INET into a con remote adder. Con remote port. This should work. I feel much more confident about this working. And this also breaks out our printing into like multiple lines, which I feel like will make this more maintainable anyway. I feel like that actually reads a lot better. Let's give this a jingle and see. Cool. And we have our remote addresses now. So let's space, 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 space. Look at that. Now, how do you do like the aligned offset print in C? Because we can actually make this C printf offset amount. It's like a percent. There's formatting the print using print. You can do like a D number or something. There's like a way you like add like a number. Percent controlling the width. Here you go. You put a number in there. So I think what I want to do, just hear me out. I think we want to do TCP establish. I think what we want to do... Oh, did we just get raided? Raid from Ian Douglas. Okay, yeah, we just got raided. Thank you for the raid, Ian Douglas. How was your show? What were you streaming about? Welcome in. Tell us about yourself. How was your show? What were you talking about? What do you do? Have you heard about those new corduroy pillows? They're making headlines. Go! Good one. So let's do this. So this will be percent 7s new line. And we will put an arrow in there. Oops, sorry. I guess we can format this more later. For now, this is fine. So let's see if we can't get an inode now. So find inum this. Why is find inum? No. Find dash inum. So do we do find slash inum this? There we go. And I guess we can do find rock inum sudo. Huh. Still not gonna get it. Let's try to get another one. This is taking forever. Oh. So there's a few different strategies we can take to intercept one of these TCP connections. My hope was that we could very quickly just, based off of the information we are returned from proc, we can just find the specific connection. Because really, I think the thing we're going to need is the file descriptor of that is returned when we call open. We want the file descriptor from when we called open, if I remember the API correctly. That sounds right. But basically, we need to do like some reverse proc hacking here. The way that libnet does this is libnet uses like the interface and goes with libpcap and just goes directly off the wire and just says, fuck all you guys, we're going straight to Ethernet. Which I want to be able to basically pick a single connection is the problem. I want to be able to pick a single one of these and do analysis on it. So inode isn't going to work. What else can we get from procnet TCP? What else can we get from here? Where was that? So there's this file here that explains these final digits. Let's see what we have here. There's an ACK, quick, ping pong, tick and soft clock, retransmit, location of socket in memory. Ooh. So that says it's the inode. The UID, the unanswered window, and then the inode is this value. And inode is right before sock reference count. So that's inode. So we are getting the right inode. Let me run upstairs and make a coffee. I'll be right back. Okay. Thank you for the follow, everyone. Thank you, thank you, thank you. So let's go poke around in proc and see what we see. So here's net. Here's net filter. So we can do stat. These are CPU statistics. So we basically want to be able to find the inode. Let's do this. You know what? I have an idea. So let's do this. We're gonna do some hacking really quick. We might have to do some like investigation work, but that's okay. So source TCP Jack. So let's run our TCP Jack list. Okay. And we will cat proc. We're gonna do some regex magic here. All of the /file descriptor. /star. So let's go to, hold on, proc1 fd. Oh my god, sudo ebash proc1 fd. Let's see what we have here. So read link everything. Oh my god. There we go. Okay. So let's now go back and we'll do read link proc everything fd everything. This is gonna take a long time. Type to grep this, and then there you go. Okay, so it is, we can find it quickly. So we'll have to find the file descriptor that it's looking for. We can do this in C. So the inode is the thing we want to do. So let's put inode here. And can we do C printf color code? I want the color. I always forget how to do this. Like, we'll make you yellow. Oh my god, this is like the worst. Here we go. Yellow. This. And then reset control frequency here. That should do it. Let's see. Exit, make, and there we go. Nope. I think I said it a double slash. Let's try that. There we go. Okay. So let's make TCP established red. And I'll come clean all this up later. I just want to get it like nice and greedy for right now. Let's make it green actually. this color here. And then reset is this here. Okay. Cool. And the rest of it we don't really care about. Except for we'll make you. Nice yellow arrow. What do y'all think? There we go. Okay, so this is the value that we will do for TCP Jack. So let's add some language here. TCP Jack options. inode. Okay. And so this will basically tell us, if we run our program, it'll tell us all of the available TCP connections we have that we can hijack. And then we copy the inode and then we pass it in. So let's pull that out and get our scaffolding in place. And then I don't know if I'll actually do the TCP hijacking today. So I'll probably, I'm fading fast. I need to go eat lunch and check in with my family at some point. So let's see. Let's get, here we go. So if list is equal to 1, do list. So we'll just do that right away. Otherwise, if arg count paren argc is greater than, or if argc equals 2, I believe. Let's see. Cool, and then if we do this, nothing. And if we do this, it's help. And if we do this, it's list. And if we do any secondary arg, inode found. Great, that worked. Cool, so... Okay, so now we want to be able to look up the file descriptor from proc for all PIDs and find, let's do a printf really quick. Printf, we'll say inode so we'll say car inode is equal to argv1, I believe. Does that seem right? There you go. And then let's go get our yellow from our list.c. And it's no longer an LLU, it's a %s. And then we'll need to convert it to an unsigned long. We'll call you I know. So how do we convert a string to an unsigned long in C? I2A? No. A2I? A2I is in standard lib.h. I think it's standard lib.h. So A2I. So int inode I is equal to why is this yelling at me? Consider using, so it's basically, hold on, let me zoom out and see what it says. It says consider using string to I instead. I'm gonna go with A2I, I don't care. Standard lib is correct, says Orzerfan. Thank you. And that's just unused. Okay, cool. So then we want to do int to okay, so inode equal to ooh, that looks rough, doesn't it? It should print the same, but let's see. And we did. Great. Oh, and we got another raid. Who's raiding this time? Security Live is raiding with a party of 34. What's going on, Security Live? How was your show? Welcome in, everybody. Welcome to the show. I'm your host, Chris Nova. Welcome to the Nova Show. Here at the Nova Show, we do what I want when I want because it's my fucking show. Today on the Nova Show, we are looking at TCP hijacking in the C programming language. Security Live is an old friend of ours. How was your show? What are you working on these days? I think last time I saw you, you were doing some magic with some sort of security camera, 3D something something. It was like you were in the Matrix. I was really much enjoying your show, but it's good to see you again. Welcome in, everyone. Cool. Thank you for the follow, everyone. Welcome in. Cool. So we have our inode being passed in now for TCP Jack. It's color coded. We'll uncomment you. And we'll say this is just user has passed in an argument, presumably an inode value. Random stuff, Splunk and Node-RED, ChatGPT plugin research and stuff. Also moderation chat with ChatGPT prompts and API for fun. Lots of incorrect bans. Awesome. Awesome, awesome. I love how the world is going to all this fancy machine learning, and I'm here holding down the fort. 1990s, the C programming language. I hope one day I go full circle on this and it becomes archaic enough to be valuable again, where it's just like going and finding somebody who can make like old-fashioned furniture or something. It's just like, oh, this is just like way better quality and like it's more exciting and there's like an actual interest for it because it is like authentic, if that makes sense. I don't know. Hopefully one day, but we'll see. Cool. So we have our inode. It's now an unsigned long, which is how it is in the rest of our code. And this yells at us because it's not handling errors. So I can say it should do error. Fortran programmers are still needing to get loads of money. Yes, exactly. Okay, so let's see. Int main. And so now what we want to do is we basically want to look up we basically want to find a file descriptor by, well, we can find the process by inode. And once we have the process, we can find all kinds of stuff about it. But let's just do this. Let's just call this, we'll make a file. We'll call it TCP proc.pid. TCP proc.c. I think this is it. I think this is what we want to do. I think we'll call it this. We'll get rid of all of this junk here. Cool. And then we'll create a new function and we'll make this in our public API. And this new function is going to be, we have print list. We're going to do a void. We're going to call this one proc by inode, maybe? Proc from inode? Do we want to use the word? Somebody pick by or from. We can do proc by inode or we can do proc from inode. We'll do proc from inode. Okay, so you're going to get an unsigned, oh, if I could type, unsigned long, I know. Is there not an inode type? I feel like I should just use an inode type instead of just doing unsigned long everywhere. We looked at this earlier. And it was inode, it was ST. inode, I think. And it was in ARPA ASM generics, I believe. Stat.h, if I remember correctly. And this is where the 64-bit, 32-bit came in, yeah. So it was ST inode. Cool, we'll just do good old unsigned long then. Inode. Okay, proc from inode. And you are going to return a new struct called proc3. Is a entry from procfs for a given and we'll look up a proc entry for a given inode file descriptor found in procnet. Okay. That looks good. And there's proc from inode. Ram inode. Okay. This looks good to me. And we call this TCP proc.c. And let's write our implementation. Proc from inode, and then basically we want to say struct proc entry. Call it pentry. And we'll initialize it, and then we'll return pentry like such. And then we will basically say, where's our TCP.c? Get rid of you. They do this. And we'll say struct proc entry is equal to proc from inode. Here we go. And then we have what? We had a print list, and we'll have a print proc entry. Change you to proc entry from inode. Okay, and we changed you to pentry proc entry from inode. And we'll do another one that is void print proc. We called it print proc entry, didn't we? Yeah. Okay, print proc entry. And you are struct proc entry pentry. Go. Add this to my dictionary so it quits yelling at me. What did I say for the other one? Here. Cool. So print proc entry. So now we're gonna get, this is gonna be all the proc data. So the executable, the process, the PID, the TPID, all of the file descriptors, all that fun stuff. If you're not following along, I hope most of you are. I don't know if you are or not. Tell me if you are or not. Talk in the chat. Do it now. Okay, so there is we'll save that code. So TCP proc. So really all we have to do here is just print F. I guess it doesn't matter. So we return our pentry, then let's go back to TCP Jack.c. Create a new function. Why does proc from inode not come in here? Am I not including? Oh, okay, I changed the function name, that's why. Okay, so TCP Jack. So it is proc entry from inode. And then we basically do print proc entry, return 0. You. So let's compile. Ooh. TCP Jack line 80 and the 8081. Proc entry from inode. Is my header all fucked up? Make. We can't link for some reason. Oh, I know why. I know why. I know why. Hold on. Hold on. Hold on. Make file. So this is source TCP proc.c. There we go. TCP proc.c. Oh, TCP proc.c needs to include TCP Jack.h. No. There we go. Okay, got it. Okay, so, and then we can TCP Jack. There we go. All right, so it's compiling now. So, written by Chris Nova. We'll have to fix all this stuff. We'll do that today too before I quit streaming. We'll fix my header here as well. Cool. So we can do -list. It lists all of our TCP Jack connections, and then we can grab one of those and we can basically paste it in. And let's go into our here, and we will do our printf. Do we want to try to find the proc information really quick? How fast can I read from proc and see? What time is it? It's 11:30. Okay, let's do this. Yellow. Okay, so we want to iterate over every PID in the proc file system in C. So we want to list dir ints, right? POSIX compliant list. This might take a while. Take a look at dir int.h. I feel like I've done this. Hold on 1 second. Let me run upstairs. I'll be right back. Woo, sorry about that. I am back. Thank you for the follow, everyone. Okay, so let's list all. Let's see. Oh, here we go. Here's a good example. Okay, perfect. So we want to do dir ints. This is the stuff I had to do in Bootcat. Okay, so we will do entries. So we'll say struct Now let's grab dir int dot. Dir entry. So struct dir int, we'll call it proc. Procfs. And then we'll say dir proc. We'll say dir open dir proc. Okay. And then basically say if dir is equal to null, we have a problem. Return here, return pentry. Okay, and otherwise we will say while double proc equal read dir directory pointer. It's called dir. I probably should have called it dir p, but that's fine. And while this is not equal to null, I think is what we do. Yes, read dir comes from standard.io.h. Yes. No, no, it does not. But printf does, so we'll probably use it later. Okay. So while proc read dir, oh, sorry, dir pointer, dir. Is only assigned but never accessed. I guess we have to do something like here. So we can do printf sent as new line. Proc dot inode dot dname, I think. Let's try this. Let's just and this should give us all the PIDs and everything. And then return pentry. So let's make, and there we go. So we should see net and a bunch of other stuff in here as well. Here we go. Yeah, all of these swaps, kcore. This is the proc file system. Okay, great. So let's turn this into a much more tidy system here. Okay, so proc d pointer proc dp proc dp proc dp. Okay, so then we're gonna do this recursively a little, well, not necessarily recursively, but close. And actually we're gonna move this up so it's a one-liner now, and we'll copy this here. So this is proc. So now we want to get every number. We'll get every. How do we do that? Mm-hmm. Why are you yelling at me? Mm-hmm. If sprintf needs to be a buffer. Oh yeah, I can't use sprintf this way. That's right. Thank you. Okay, so our proctor pointer. Oh. Ring. Oh yeah. Okay. All right. 1 second. I always forget about a sprint F and C. This is why I always was instinctively trying to avoid it. Proctor. And then I guess I can make this a fixed size. Oh, that's fine. We'll make it dynamic. It's fine. Okay, so proctor this opener. Oh, see, this is why. Uh, 48 maybe. That should be plenty, right? We'll do 64. It'll be more than fast enough. Okay. So there we go. Lack thereof. Yeah, I know. I know. Okay, so we have proctor pointer is there. Also, we'll copy this while loop again. So this be proc hub dir pointer. While proc sub entry. Cool. So now we need to look for FD. Mm-hmm. Oh. If proc, how do you do a string compare? Ugh. Oh. String compare. Recop. So this is going to be proc sub entry dash d name, and we're going to compare you to FD. Oh, and it return. You have to do not equal to something. God, I hate string comparency. It's like not equal 1 or something, and like returns an int value. There you go. Return value equals 0. You like have to compare it to its like an actual value. Okay. So string found FD exists. So Now we want to, let's do to do read link file descriptors and to do assert file descriptors against inode. Why don't I just change it to and do a continue if it fails? On 27. So you're saying sprint s fd. You're saying if equals no continue, and then I don't have to do. We are in directory. Good call out. Good optimization. Good job. Sorry, I'm turning my microphone. Hopefully that's a little bit louder. I think that's actually the spot y'all wanted at. Okay, so that's a good call out there. So we don't need our string comp anymore. And so now we basically want to do oh, so here's an example. Look at this example I found. So this basically says we do rock. So this, we can do it in one loop here. Check this out. So I'm gonna actually just nuke that for right now. Okay, so this says we can basically do dir p is open dir proc. Watch this. It's slash. We can even optimize this even further. There. And then we basically say, while we can take this line, while read dir proc dp is not equal to null, and then we basically say if proc dentry d type equal to dt link, then we can do printf. Let's just print it out really quick. I guess, how do we do a read link? It's car. So it's a path, and then it reads it onto a buffer, and then a size. So the path will be... Do I have to build the path? I guess I have to do this. Okay, so car... Oh my god. Car... Path, we'll say, is 64. This is starting to look familiar. And we'll say sprint f path rock. Oof. Can you link where you found the 3 dots? Never seen that. I think so. So I found it here. Send sprint F3 maybe to avoid buffer overflows. Sure. Oh, you are size T. Format. I think that is just an example. See the comment. So we don't think that's gonna work. All right, I can go back to what we had it before. That will help us with this anyway. I already lost that example. Anyway, we'll just go back to what we did before. Oh. Basically. Okay, so for everything in proc, we read dir, sub entry, print f, proc, print f there, in file descriptor directory, if proc subbed entry type is equal to a link, do read link here. Okay. So then sprint and print f. Okay. So that is that. Continue. If we can't open the file descriptor directory. Okay, so now we're in the file descriptor directory. And we're going to do a read link here. So this will be another of these. So this will be proc fd path 64. It's going to look an awful lot like this. This will be proc fd path 64. Proc entry there, and this is %s proc subbed entry. Okay. D name. And I guess we can compare the inode here. We want to just compare the inode. Do we think that that's? Do we think that? Yeah, I think that will be the inode. We can compare, right? Let's just do this really quick. Read link. Proc file descriptor paths. What is read link? Oh, I hate how it kills my argument hinting. Path buffer size. Read this onto the R FD onto FD size 64. Yeah, why not? good. Yeah. Okay, so we read the link onto procfd, or sorry, we read the link onto fd, and so let's just try printf. And I guess before we do this, if prox equals dlink and proc, sorry, what is it? And proc subentry inode. What type is this inode? Let's go see. It is an inode T. There is an inode T type. Standard type inode T. What are you? Just call you long type. It's an unsigned long int. All right, so we're gonna adopt this. This is in dirint.h. We're gonna bring this into our API. So where are you? Include dirint.h. No worries. And where's our unsigned long? I know you're in here. Try it without the D inode match. I don't think it will work. Yeah, I'll go clean up the rest of that loop in a second. And I guess for now, here, I'll do this. Here, that to do will help me. Okay, so we'll go back here and finish one thing at a time. You think just try it this way first and just print it out. Cool. And so we'll print f content is equal to this and fd. Okay. Let's go read our code. So we read dir here. 64. I tried stat on one of the files in procpit fd and the inode did not match. We'll figure it out. I already did the correlation earlier in bash. I'm confident the correlation is right. We're just gotta get my C code working. I know we'll be able to find it in here. I have no doubts there. Okay, so where are we segfaulting? Oh, we need a new line or it's not gonna return. There we go. Okay, so there's 1, 2, 3. So it's somewhere in here. Probably this line here. Yeah, I'm not gonna, Lat3, I'm not gonna compare against the result from read link. I just coded that because that's what we'll do after the match. Sorry, that's distracting. I'm trying to figure out why I'm segfaulting right now. Okay, so it's here. buffer 50. And J. Six. Buffer is here, so we write into this. Maxlin. D name here. Opender Proctor. Proc subentry. Reader proc subder P. So we think that something's broken here. Just curious. Mm-hmm. Oh. There we go. Okay. It was a typo. Cool. All right. That's good. Okay, so we basically did content, rock, deleted, dictionaries, English, and then 3. Closed you and close you. Okay, so basically we do the check here. inode to inode. And this is LLU. Okay. So comparing to 1, why is inode 1? Oh, because that's what I'm passing in. Okay, so make in TCP Jack list, grab an inode and pass in our inode, and then there you go. And then we do think that grep for I do -E. Guess it's not in there, and we don't. So here we know that this is 1, and so we know if we do read link proc star fd star and we grep for this, it's in there. That's where we're going to compare it to. So we need to compare. We need to actually do the read link here. So the compare isn't going to work up here. So maybe this is what Leth3 was trying to say. I don't know. I was focused on something else at the time. If this was what Leth3 was trying to say, then good job. You're super smart. And if it's not, that's okay too. I still love you. Okay, so there's our content. Yes, okay. I hear you. Cool. So we read the link. Okay. And so we want to see, do we want to do a string contains? Do we want to do a scanf, basically? How do we want to do this? I think maybe a scanf. Let's just do a string contains right now. A good old stir. And there's another stir compare we can use, but we'll just use stir for right now. Which I believe stir is in string.h. Is it string or strings? I think it's string.h. Okay, so if stir stack, and we'll change you to let's do this. For now. Okay. We're just gonna get it working and then we'll make improvements later. That's like my style. Okay, so let's change our API to now take a car pointer. Content FD. Let's see. We'll make improvements to that condition as we move forward. I just want to make sure we're cool. So we'll grab a inode and there. Cool. Would be sprint f socket and then compare that result to read link. Yeah, I think so. So that was a Spotify browser cookie. I mean, I have no idea what this stuff is. Let's try this one. Chromium. This looks like it's this is a buffer overflow if I had to guess. So we need to reset this every time, basically. There we go. Okay. So you're saying, Luthri, you want to basically, instead of doing a stir here, you're saying we basically build it and then do a compare that way. So you're saying car needle. We'll keep with 64 just for good numbers here. And then you're saying we want to do a SN print F. Needle. And we're basically gonna say size 64 socket LLU, and then we put our And I guess this is a string now. We'll come back and we'll do the inode plumbing with the inode type in a little bit. We'll just get it working for right now. Not every loop. Yeah, I'll move it up. Don't worry. I'm just typing it out. Don't worry. You're one step ahead of me because I have to actually type it out. You just go, oh, she's gonna figure it out, and then you can just move on to the next thought. Okay, so socket us, and then this is our inode. Cool. Don't worry, I'll move it up. Stop freaking out. So read link is here. Needle is 64. S and sprint F. Does this look right? I think it does. Okay, so we'll get our needle. And we'll put it here at the very tippy top. Cool. And then we want to do a string compare. I think it's string comp. Cool. Comp FD needle. Equals 0. String comp has to equal 0. There we go. Okay, awesome. Okay, so let's start to pull some data out of here now. So let's go to our proc entry. So we want, I know we want PID as a type. PID T PID. Okay. R what else do we want? ASCII. We'll just do this for now. Carcom PID. And then I guess the file descriptor path, the FD path. Yeah, because we're gonna have to pass this file descriptor into the network library. So the file descriptor is an int. I think we want that. Cool. So let's close this and TCP proc. Okay, found the process. So entry. Can we add things here? Yeah, let's just do a new one. TPID. And we had int. Okay. So PID is going to be this. So that's proc entry name. So it will be A2I and proc entry name. Okay. And what do we do? PID T like this? There we go. What is PID T? S32. An int. Oh my god. Okay. Cool. So car is equal to, I want to read a file's content. Com F is equal to F open. Oh. Proc com F. And then we'll do another S and F. Proc com path 4. So this is proc S com proc entry name. Okay, and F open proc com path there. Okay. R. Right? What is F open to? Yeah, modes R. Okay. If F equals null. Why is this yelling at me? File. If equals null, what did we do here? We just return for now. Entry. Okay. And then we can do it one character at a time, am I right? Com F character is equal to F get C. F. And then we need to write it onto our buffer. Our com. So we will, appending to a fucking buffer in C. Oh, goodness gravy. Okay, how do we do this? This code is so hacky, you guys. Whatever, I don't care. Just make it work and then come back and clean it up with a fresh brain later. Okay, so proc com path I is equal to ch. And ch here is and then we want Standard lib and string.h. Cool. So that's com. So PID is equal to PID. Com is equal to com. And TCP FG is equal to index may have value of 64, which is out of bounds. Ah. Proc com path. Ah, this is the wrong thing. This is com. There we go. So why is... Where's my list dots? Ah. There it is. Okay. Missing a period there. Okay, so now we want our TCP file descriptor, which is an int, which is the file name. So this is A to I of this. It is proc sub D entry name. Am I right? I think that's... These are the file descriptors. These are the int values we get for... maybe use fread instead of fgc loop. It's fine for right now. I'll just keep it. I'll come and make all kinds of optimizations and improvements to this later. I want to get the TCP file descriptor, which is an int. And I guess for now it doesn't matter. We'll just do PID and com for now. Make sure this compiles. Okay, and let's print f. Send D. New line. And this is entry dot PID and pentry dot com. Okay, so let's make an TCP Jack list. So we get some file descriptors and we grab one. And we will do this. All right. We got some. And you were correct. The name of the file is the FD number. I know, but I'm thinking, I don't think we can pass that into the network API code directly. Is I guess what I'm trying to say. So pentry com is garbage. So we can use this. So we have file, we have buffers here, and we have F open. So we can basically do this to fix it. F read. So our buffer is size of and 1 and F. And then we want to end it. So C out from com. Oh, we're not doing C++. Okay. Com allocated on stack. It will no longer exist when the function returns. Ah, thank you. Am I right? Oh god, now we have to fucking allocate it in the higher. Ugh. We need to get it on the heap somehow. I don't want to have to deal with this right now. I just want my code to work. This is so dumb. I could have written this in Rust in like 10 seconds. Why am I doing this with my life? I have no friends. This took an hour. This was supposed to take fucking 10 minutes. Now we have to get the new line off of the end of this. I guess for now I can just hack through it like that. There we go. Okay. So TCP list. Brave. Cool. Ah. So I think what I want to do now. Commit SSM. Okay, so I think one of the things I'm gonna do is I'm gonna come through in the future and I'm gonna like make the list nice and pretty, and I'll probably include the proc lookup code. I'll keep this code as is, I think, but I'll probably make the list a little bit more beautiful. And so like when you do a list like this, it'll have the proc details and stuff in here, and like I'll just format this so it's nice, neat, and pretty, and I'll do the whole thing and make it all beautiful so that you get like a nice user experience here. And then I'll make it clear that this is like we use the inode as like the identifier, and you just basically can pass this in. And then if you do like pick one of these, it'll do this, and then it's basically going to be like, it'll be like netcat semantics. And so it'll just attach itself, and then it'll do all the TCP plumbing for you automatically. And hopefully we can just intercept it and try to hack the sequence and acknowledgement numbers in a TCP stream. I don't know if we can or not, but we're going to find out. And if we can't, we'll find something cool we can do in the process. So anyway, I think that's a good stopping point for today. My brain is pretty much fried at this point. We'll keep hacking on it, and we'll keep cleaning the code up and stuff, but it's a good starting point. So I'm gonna get out of here, you guys. I'm done. I'm gonna go take care of my family. I gotta go take care of myself. Probably go for a run. Maybe lift some of my body weight off the ground in the garage in my rock climbing gym. I don't know. We'll see how it's good. Thanks for the stream. Yeah, of course. So who do we want to raid? Any suggestions? I don't know. Thanks for your help, Lethri. It was good to see you all. We have, let's see, we can go look at Twitch together. So there's Rox Codes. This is one person. The other person is RWX Rob. And I think that's pretty much everyone I know. So Rob is doing container images. Rox Code is doing finding out if I want 100K. This looks a little bit much for me. I'm gonna do Rob. We're gonna raid Rob. No problem. All right, we'll see everybody next time. I'll try to stream more. I'm gonna get out of here. Thanks for hanging out, everyone. It's been real. I love you all. We'll see you next time. Have a good day. You're beautiful people. Keep up the good work. Be nice to each other. Life is short. Don't cast stones on social media. Cyberbullying is bullshit. If you want to enact real change in this world, roll up your sleeves and go do real activism. Don't just fucking yell at people on the internet. That's just gonna lose for everyone, yourself included. You know, there's more to this world than just putting other people down. Lifting people up is difficult. Putting people down is easy. So, I think you're all wonderful, beautiful people, regardless of if you've made mistakes or not. I think that you all have the potential to be better people every day. And so I love you, and we'll see you all next time. Great day.